Hi everyone, welcome to my channel TCU for Olympiads and JEE. Today I am going to continue with my series Binomial Theorem, and this is the fourth video. So 04. Now moving on, we have already done 3 videos on this topic, and 3 videos means 9 questions. So today this is the question 10. Is the question 10, and today we will do question 10, 11 and 12. If the coefficients of pth, p plus 1th and p plus 2th term in the expansion of 1 plus x whole to the power n are in AP, then so this expression holds true. Yes, this is a similar question of this sort, a previous one. This was question 9. We solved it in one way. This is another similar question but a little generalized. There was first, second, third. Here pth, p plus 1th and p plus 2th. Okay, then let's start solving the question. Okay, let's write the expansion 1 plus x whole to the power n is equals to 1 plus nc1 then x plus nc2 then x square. I cannot suppress the background noise today. What can I do? There will be few background noises. Please ignore that. That's what I can do now. Means I can request you to ignore the background noises, and nothing else that could be done by me right now. Okay, it is okay. This is the expansion. Now let's find the pth term. Pth term will be, one can easily guess it. It will be nc n minus p ncp. One can write it ncp. It will be simpler. N minus p is equivalent to ncp. That is common, but ncp it will look a very simpler. Yeah, less upon water. ncp if is it ncp, second term is 1, so third term is 2, so ncp minus 1. Yeah, now I am correct. And now pth, p plus 1th term will be, let's see what will it be. P plus 1th term is, what will it be? It is ncp. Now p plus 2th term, p plus 2th term is ncp plus 1. ncp plus 1. This is the p plus 2th term. Now let's write the statement of AP here. No need to write that way. It will be simpler in another way I am writing. The common difference will be equal. This is the statement of AP. So is NCP minus NCP minus 1 is equals to NCP plus 1 minus NCP. This statement is true for every AP. Now let's divide everything by NCP. all the four terms by NCP here. So we can write NCP minus 1 by NCP is equals to NCP plus 1 by NCP. NCP plus 1 by NCP minus 1. Yeah. Now this implies, so the implied sign will be here. So another implies. So we can write here. What can we write? We can write 2 minus n factorial by p minus 1 factorial, and then another n minus p plus 1 factorial. This is the numerator in the second term. Another n factorial divided by p factorial and n minus p factorial. N minus p factorial. So this n factorial gets cancelled. P minus 1 factorial gets cancelled with p factorial, leaving p as the remainder quotient, and this to cancel, leaving n minus p plus 1 as the quotient. N minus p plus 1. Okay, one understood this expression maybe. Now I am just rubbing this expression due to the shortage of space. This expression needs to be rubbed out, and give main expression which will be from which we will be able to solve the question needs to be wrote. Okay, then it will the main expression will be p by n minus p plus 1. N minus p plus 1, and this will be equals to, what will be this be equals to? I have already taken the minus 1 in the left hand side, so there will be in the next expression what will it be? Another, we have to simplify this thing, right? Let's simplify. How will we get it? Okay, this n factorial by what here is it, p plus 1 factorial. Okay, we need not write again, we can easily solve this from our analogy from the previous one. In denominator there will be p plus 1, right? P plus 1 factorial will be there in the denominator of the numerator, and p factorial will be there in the denominator of the denominator. Both of will cancel, and p plus 1 will be remain in the as the denominator. In factorial, n factorial will get cancelled both sides. There in the numerator is n minus p minus 1 factorial, and there is n minus p factorial here. So there will be n minus p will remain. N minus p will remain, which will n minus p will remain, which will go to the numerator here. N minus p. It's remain, and we can write this as p plus 1 and minus 1. This can be written plus 1 minus 1 is allowed. Plus 1 sorry. The first one will get minus 1. Now this thing plus minus 1 is added here. Now this what can I do? Okay, now let's just solve this equation. This equation is a very bit complex one. Let's see if some simple method comes out to solve this okay. Now we can let's solve in the only way we have remaining right now, that is 2n minus 3p plus 2 whole multiplied by p plus 1 p plus 1. This thing it will be equal to n minus p plus 1. Okay, no need to write that plus minus 1. It just makes the problem. Yeah, I'm left this. It just makes the problem a bit difficult to think about. Yeah, now we can write this as n minus p multiplied by n minus p plus 1. N minus p plus 1 is the part. Now solve for n from here. We have n square term there. Now I can write another step here. We will have okay. There will be a n square here. Now n term minus np means minus 2pn minus 2pn. Now there is a term and minus, not a minus 2pn. There will be another minus 2p plus 1n. Okay, let me erase this. Minus 2p plus 1n. Yeah, minus 2p n can be written, but can be done. Minus 2pn plus 1 plus 1. Now plus n plus 1n. So this can be written. Due to the lack of space, I am rubbing a few parts. Just after solving, I am rubbing that part for the space constraint. Now 2p minus 1 multiplied by n, then there will be a plus p square and there will be another minus p. This is the expression on the RHS. So I thought RHS will be a bit simpler, so I first solved that. Now let's see how will we solve this expression in the LHS. We first let's find the n terms here. 2p plus 2n will be there, and 2p plus 2 whole multiplied by n. Then all constant terms are remaining. Now this will be minus 3p square, then minus 3p square, minus 3p square. Now there will be a 2p. Okay, 2p and minus 3p, so another minus p, and there will be a plus 2 here. This minus p will cancel with this minus p. Now I am writing from here to here. I am writing here. Barring this part. Now here we'll write n square minus there will be 2n minus 1 minus 2p minus 1 minus 2p plus 1 minus 2p minus 2. So minus 4p minus 1. Where this is minus 4p plus 1 and minus is taken outside the bracket. So this n is remaining and this p square plus 3p square is 4p square minus 2 plus 4p square then minus 2 will remain, which will be equals to 0, and hence our solution is done and question is solved. So such a complex question, it can be a good question for the one question series, but I solved it here. It is a binomial theorem, also a nice question which becomes good to solve. This expression is written, we divided by NCP. This expression was found out. Then we just solved it and came to our conclusion. The concept is easy, but the working is a bit difficult. From here we move downwards, and this is the last step. Okay. Now moving on to our next question, question 11, and the second question for today. Let's see how much this question will go. This is question 11. Yeah. The sum of all rational terms in the expansion of 3 to the power 1 by 5 plus 2 to the power 1 by 3 all to the power 15. We have to find the sum of all rational terms only. Now, see, this question will get simpler if we just apply a simple logic at the beginning only. Then it will be easy, or else it will get a very bit complex one. We have to just think about which terms will be rational and which rest of the terms will be irrational. Pause the video and try the question. I'm moving on to the solution. The answer is 59. Those who are correct, please comment below that they are question 11 correct, and those who are wrong, please also do the same, that question 11 wrong. Okay, now this is 3. Let's solve it. How I approached the question and found out the answer. This expression was the given expression to us, and we can write. See, first of all, the logic I told at the beginning of this question was, see, LCM of 5 and 3 is 15. So the rational terms will be of the order, means multiple of 15 if the term number will be multiple of 15. You can check it out, as or else this by means remaining term will remain same. If only number which is means 15 multiple of 15 only can remove this denominator from the powers of both of it. So here multiple of 15 between the range less than 15 is 0 and 15. So 0 and 15 is our main motive to find out, that is the 0 and 15 means the first term and the last term. These are just the terms we need to think about, means find out. 0 and 15 means the first term. This is r equals to, means the value of r I was talking about basically. This is the value of r I was talking about, 0 and 15. Now let's write the general term. 15 CR multiplied by 3 to the power 1 by 5 minus r. Sorry, 15 minus r by 5. 15 minus r by 5. 15 minus r by 5. This at this point no other term will be, means both of these term will be so called integer or rational. Means integer needs to be found out such that the term will get rational. None of it will get integer if this r's value is not a multiple of 15. So r is equal to 0 and 15 we already know. We just for r is equal to 0, it will be 15 c 15. 15 c r is equal to 0, then 15 c 0. 3 to the power. Okay, 1 minute. This is 15 minus. Wait a minute. 3 to the power 15 will not be. Okay, I have gone wrong. Where I have gone wrong? Wait a minute. Oh, sorry, I have done a simple mistake here. This by will be from here. Means 15 by 5 will also be a term. So 15 minus 0 by 5 is 3. 3 cube and multiplied by 2 to the power 0. 15 c 0 is 1. 2 to the power 0 is 1. for r is equals to 0, we will write this term to be equals to 27. Now for r is equal to 15, I am writing r is equals to 15 now. If r is equals to 15, then 15, see 15 will be a term here. This part will be 3 to the power 0. Then this part will be 2 to the power 5. Now from everything I can write this. This is 1, this is 1, this is 2 to the power 5 is 32. Adding 27 plus 32 is 59. We got to our answer. 27 plus 32 is equals to 59. And I found out our answer. So this is our answer. Moving on to our question 12 and the third question and the last question for today. This is the question. A very complex looking question. Yeah. And a very complex looking answer as well. So one can try this question out and I will write the answer just at the end of the question. Then only one will go out to the comment box and comment that if he or she is correct or wrong. Because this writing the answer once is already take a part of the page already. It will take a part of the page and the solution will also be a lengthy one. Okay, let's see. Okay, these are the terms, very complex looking terms. We have to find the coefficient of x to the power r. This is the coefficient we need to find. One may pause the video and try the question. Okay, I am moving on to the solution. Answer will be given at the last of the solution. Okay, now this is a GP. If one observes it very powerfully, it is a GP with common difference R. This is what can be written. I am writing common ratio CR. It will be a very R is there already in the question, no? So we can write CR. This is CR is x plus 3 divided by x plus 4. Okay. CR is x plus 3 divided by x plus 4. CR means common ratio. Okay. Now, so there will be number of terms in each of the expression term. Each of the term, the number of terms will be. My word seems to be confusing. Means x plus 4 whole to the power n as n plus 1 term, another n plus 1 term in the second term. What can be told? Both are terms only. Okay. Now, and one thing, all n plus 1, n plus n, 1, n plus 1 will not get added. The final result will also have n plus 1 term. This is a very good point to be noted. All the terms will add up and each of the term of the first term of each expression will add up and give out the n plus 1 terms only in the final answer also, if this expression is simplified. Now let's start with the solution. Let's write the sum of first n plus 1 terms of the GP. This is a GP, we already know. Now this GP in a GP, the sum of terms, this is always less than 1. This is always okay. I'm removing the second bracket. It seems a very bit bad. This is less than 1. Always less than 1, not even less than equals to. This is always less than 1. X plus 3 is always x plus less than x plus 4. Okay. Now I am writing the sum of a GP here. First term means I am just finding the sum. X plus 4, x plus 4. Okay, it's giving some problem here. Let me see how can I resolve it, or else I need to do something else. Okay, let me do some work. X plus 3 by x plus 4. Now all multiply a whole to the power n minus n plus 1. Okay, n plus 1 here, divided by 1 minus x plus 3 by x plus 4. 3 by x plus 4. Now simplifying this is another tedious work to be done. It needs to be done. Nothing else is option there. See what will be the tedious work here. It will be, there will be the denominator in the numerator here will be x plus 4 to the power n plus 1, and the denominator here will be x plus 4. Cancelling those, there will be x plus 4 to the power n in the denominator, which again gets cancelled from this term, x plus 4 whole to the power n. I am not writing those long statements here. Here the denominator will be x plus 4, here the denominator will be x plus 4 to the power n plus 1. Cancelling those, we will get x plus 4 whole to the power n, which will again remain in the denominator, and we can cancel that term with this term, and indirectly x plus 4 to the power n term will get cancelled. In the denominator there will remain x plus 4 minus x plus minus 3, which will be 1. So this term will also not remain. Just the thing which will remain is x plus 4 whole to the power n plus 1, then minus x plus 3 whole to the power n plus 1, then minus x plus 3 whole to the power n plus 1. This is the term which will remain from here, x plus 3 whole to the power n plus 1. Okay, now we have moved a bit so-called closer to the question. Now let's write the expression here, a very big expression. I am writing the rth term of this expression. Rth term of this expression will be NCR minus 1. Oh, no need to write the rth term. We can write the power r. So r plus 1th term means we can use r easily. Okay. Let me see how one can approach this question. I can write this thing as 4 plus x whole to the power n plus 1. Because I am doing this thing because x power will then gradually increase, which will, I guess, makes the question a bit easier than what it would have been if power of x will gradually decrease. Let me see how it becomes easier than the previous one. This part will be, so the general term means x to the power r term will be, oh yeah, here there will be an easier part, NCR multiplied by 4 to the power n minus r plus 1 minus of NCR multiplied by 3 to the power n minus r plus 1. So, oh yeah, the answer already came. NCR x to the power r will be there in both the things, but we need to find the coefficient, so ignoring that, we can write n minus r plus 1, and there will be a minus there, 3 to the power n minus r plus 1, n minus r plus 1. Please bear with my n. My n sometimes seems similar to r, but means there are two problems, my handwriting as well as the mouse. I think to be done. This is we can write this term again as n factorial by n minus r factorial multiplied by r factorial. Sorry everyone, I don't know why the video recording paused at this moment. Okay, I myself continued, but the recording has paused, so I am just revising how I told, and nothing needs to be revised only. This can be written as n factorial by n minus r whole factorial into r factorial into this term. Okay, now this is the thing I told after. Means after the video recording paused, the video went for nearly 30 or 40 seconds. And with this note of thanks, I am ending the video here. Thank you very much for watching the video till the end.